Hey everybody, Mrs. Bianchi here. We're going to be using Halloween candy to understand a little bit more about what we call distributive property. On the screen here, you see that we have 21 pieces of candy. So we have 12 Reese's Peanut Butter Cups. And if we were to add the 9 Snickers to that and figure out how many total pieces of candy we're talking about, this plus this would give you 11, and this plus this would give you 21. So we have 21 pieces of candy. Now our task here is we're going to try to come up with containers because we're going to put these containers. We have to figure out how many of these containers do we need. So I'm just going to clone this. Is it 2 containers? Is it 3 containers? Is it more? Where we're going to try to have the greatest number of containers that would have the same amount of Reese's Peanut Butter Cups and Snickers inside it. So let's find the GCF of 12 and 9. And how do we do that? We're going to make factor trees. Now, it's always a good idea to, in your tree, to put what you think the GCF of the two numbers would be. So let's say you think the GCF is 3. Put that in both your trees. And then ask yourself, what would the other factor be? So over here, 3 times what equals 12, and that would be 4. Over here, 3 times what would be 9, and that would be 3. Now, if you're not sure how to use the shortcut on how to find the GCF, then we would just kind of keep going with our tree until we have all prime numbers. And let's bring that 3 down. Now, I color-coded this on purpose, and some of you might be able to figure out why. So the prime factorization for 9 is right here. The prime factorization for 12 is right here. And you may recall that when we find the GCF, we make a Venn diagram. One of the circles would be the prime factorization for 12. The other circle would be the prime factorization for 9. And the numbers that we have in common, which in this case would be the number 3, would go where the circles interlock. And if there's only one number that's in common, then that would be your GCF. So the GCF of 12 and 9 is 3. So I'm just going to write that number down here, 3. And let's write it as the GCF. Now, in our context here with the Halloween candy, that means we're going to fill up 3 buckets. So we just have to figure out, when we fill up the 3 buckets, we have to figure out how many Reese's are going to go in each bucket and how many of the other candy, which are the Snickers. So we'll use an S for our variable for Snickers. And we're actually going to put a number here. Now, how do you figure out what that number is going to be? Whatever the GCF is, which in this case is 3, that's what you divide into each of these numbers, right? So remember, we had 12 of the Reese's and we had 9 of the Snicker bars. So if we divide both of those by the GCF, which is 3, 12 divided by 3 would give us 4 Reese's, and 9 divided by 3 would give us 3 of the Snickers. So what does that mean? That means that if we divide up this, right, so this guy gets a Snicker, this guy gets a Snicker, this guy does, Snicker in here, here, and here, and a Snicker here, here, and here. Now for Reese's, when we divide those up, remember we did 12 divided by 3, so that means each of the containers will get 4 of the Reese's. So if we put the 4 here, 1, 2, 3, 4 for that container, this one gets 4, and this one gets 4. All right, so we have 3 containers, which each have 3 Snicker bars and 4 Reese's Peanut Butter Cups. Now, one of the things that's important for you to understand, if we actually simplify this, you would add the 4 plus 3, which would be 7. We have 3 groups of 7 pieces of candy, which if we were to actually multiply this out, we still have our 21 pieces of candy. When we added, we had 21 pieces of candy. When we redistribute it, we still have 21 pieces of candy. But when you distribute it, it answers the question, how many Reese's are going to go in each of the 3 containers? How many Snickers would go in each of the 3 containers for a total of 7 pieces of candy? So other things I want to point out about this idea of using distributive property is in word problems, when they use the words the same and greatest number of, then they're talking about the GCF, right? Because we're going to have 3 containers, which are each going to have the same number of Reese's in it and the same number of Snickers in it. And they're all identical, right? Isn't container number 1 have the same stuff as container number 2 and container number 3? So it's important to understand that when you're distributing, Nothing is getting taken away. We're just reshuffling the items into groups, and in this case, groups of 3.